topic of this video is how do you name alcohols? Principles apply that you've learned already. So you've got the prefix, part of the name, which tells you the names and locations of the substituents, the parent, the longest continuous carbon chain, and then the suffix. It tells you the type of compound. So we've seen ANE for alkanes, ENE for alkenes, and YNE for alkynes. And now for alcohols, you have the OL ending for all. And the priority is to number the parent carbon chain, is to minimize the hydroxyl group, that OH group, in the parent carbon chain. Okay. And the other rules should be familiar or similar. The rules, how you go through the process of naming is going to be similar to how you name other compounds that you've named already. So this example. So remember, the priority is to number this compound in a way to minimize the location of that hydroxyl group. So 1, 2, 3, 4, 5, 6. The way I've numbered that in red has the hydroxyl on 3. If I were to number it from left to right, 1, 2, 3, 4, 5, 6. What's in green, the hydroxyl would be 4. The proper way to number it is in red because 3 is less than 4. 6, hexa, is still the prefix for hex. So the parent is 3 hexanol. Okay, that OL ending, that you've got an alcohol, and the 3 is needed to tell you where the hydroxyl group, the OH group, is. The only substituent here is what I've circled in red there. That is a methyl group. And it is on position 5. So 5, we have to use the red numbering for nomenclature to make the hydroxyl group as low as you can. So the full name of this alcohol is 5-methyl 3-hexanol. So very similar to alkane nomenclature, but the priority is minimizing where the hydroxyl group is. And some more practice. So here, we're going to start numbering closest to the end where the hydroxyl group is, the OH group. That's the priority to minimize. 1, 2, 3, 4, 5. I made a fork in the road at carbon 5, but there's more carbon if I keep going to the left. 6, 7, 8. If I had went straight up at carbon 5, there's only 2 carbons there. So you go where there's more carbon. So 8 carbons long. So octa, but it's the hydroxyl's on carbon number 2. So the parent is 2-octanol. because that's where it's an alcohol and the hydroxyl group is on carbon number 2. This group is a substituent. That group is a substituent that I've highlighted in yellow. So we have 3-methyl and 5-ethyl as our substituents. Those are going to be the prefixes in the name. We still go in alphabetical order. Whenever we assemble, E comes before M. So the full name is 5-ethyl, 3-methyl, 2-octanol. That's how you would name that alcohol. Okay. Minimize the location number of the hydroxyl group. One last example, what do you do if you have a cyclic alcohol? The priority is the hydroxyl is always as low as you can go, so that's always carbon 1, 2, 3, 4. I could have numbered it counterclockwise, and it still would have been 4. That's 4-methyl cyclo, because it's cyclic, you have to say cyclo. It's a 6-membered ring, hexanol. Okay. Now you might ask, why didn't I say cyclo-1-hexanol? One is assumed as the lowest number in a cyclic alcohol. Just like 1 is assumed as the lowest number in a cyclic alkene for a double bond. So 1 is as low as you can go for the hydroxyl group in a ring. No need to put the 1 in the name. That's how you name alcohols. Very similar to alkanes, but the priority is minimizing the location of the hydroxyl group when you go to name these.